Hello students, let us start the new chapter, chapter number 12, Exponents and Powers. This chapter, Exponents and Powers, is not a new topic. We had learned this in class 7 also. To begin with, let's discuss about exponents, why these exponents are required. Exponents help in writing large numbers in a shorter form which can be read, understood, and can be compared easily. A number placed in a superscript position to the right of another number or a variable indicates repeated multiplication. If very large numbers are difficult to read and to understand and also to compare, this can be made easy by writing them using exponents. The simplest exponent form will be in this format: a raised to the power b. It is read as a raised to the power b. Here a is called as base, b is called as exponent. Let's see some example. Here when I write a square, it indicates that a is multiplied 2 times. A times of a gives a square. Suppose if the same a is multiplied 3 number of times, this indicates a cube. 3 raised to the power indicates that 3 is multiplied those many number of times. Say for example, 3 is raised to the power 8th power. It indicates that 3 is multiplied 8 number of times. And to read this particular number multiplied 8 number of times, it becomes easy if I write 3 raised to the power 8. It's very easy to write and also it is easy to understand. In the expression 2 raised to the power 5, 2 is called the base, 5 is called the exponent of the power. When I have a number, I can try expressing that as exponential form. So for example, 32. When I multiply this 2 5 number of times, I get 32. It can be written as 2 raised to the power 5. Similar way, 64 is 2 raised to the power 6. 128 is 2 raised to the power 9. It's not 9, it's 7. Same way, 1024 can be expressed as 2 raised to the power 10. Now let's solve a question. Express 252 as power of 2. To know how to write as power of 2, we need to find the prime factors. For that, let us follow prime factorization method. So 256, I have to do prime factorization. When we divide by 2, 2 times of 128 is 256. 2 times of 64 is 128. 2 times of 32 is 64. 2 times of 16 is 32. 2 times 8 is 16. 2 times 4 is 8. 2 times 2 is 4. 2 times 1 is 2. When we know this part, we can write 2 into 2 into 2 into 2 into 2 into 2. It can be expressed as 2 raised to the power 8. This 2 raised to the power 8 is 256. Let's look at another question. In this question, I need to compare which one is greater, 2 raised to the power 8 or 8 raised to the power 2. What is the meaning of 8 raised to the power 2? 8 raised to the power 2 means 8 is multiplied 2 number of times, it is 64. 2 raised to the power 8. 2 is multiplied 8 number of times, it is 256. Clearly, 2 to the power of 8 is greater than 8 to the power 2. Let us try understand that what are negative exponents. For any non-zero integer a raised to the power minus m is 1 by a to the power m, where m is a positive integer. A raised to the power minus m is a reciprocal of e to the power of m. We can say that a raised to the power of minus m is the multiplicative inverse of m. It means that when I multiply a to the power of m with a to the power of minus m, we get 1. Let us solve this question. Evaluate minus 6 to the power minus 2, and the second one is 1 by 2 to the power minus 6. We know that a raised to the power minus m means 1 upon a to the power m. For the first one, 6 to the minus 6 to the power minus 2, it means we can write it as 1 by minus 6 whole square. When this negative 6 is multiplied 2 number of times, we get it as positive 36. So the result is 1 upon 36. For the second one, 1 by 2 to the power minus 6. So it is written as 1 upon 1 by 2 to the power of 6, which is 1 upon 1 by 64. This can be written as a reciprocal and multiplied. So it is same as 1 multiplied to 64 upon 1. We get the result as 64. Calculate minus 1 raised to the power 2. Minus 1 raised to the power 2 is minus 1 into minus 1, which is 1. Minus 1 raised to the power 3 is one more time I had to multiply minus 1. We get the result as minus 1. When negative 10 is multiplied 2 number of times, we get it as positive 100. When negative 5 is multiplied 3 number of times, we get minus 125. You must note this. Whenever we have a negative number and the power is an even number, then the result we get is a positive number. Whenever there is a negative number and the power is an odd number, then the result is going to be a negative number. This particular point you must note it. Now we shall take up another very important concept called as laws of exponents. These are the rules of exponents. They are called as laws of exponents. What is the first law? The first law says that if a is any non-zero integer, that is bs, and m and n are the integers which are the powers, then a to the power m multiplied with a to the power n is a to the power of m plus n. For example, if we have minus 2 raised to the power 5 multiplied with minus 2 to the power 10, the result will be minus 2 to the power 5 plus 10. Actually, there is a print mistake here. It's minus 2 raised to the power 5 plus 10. We get it as minus 2 to the power 15. Suppose if the question is multiply 32 with 34. It's not 32. Again, there is a mistake in the print. This is 3 raised to the power 2 and 3 raised to the power 4. In such case, 3 raised to the power 2 into 3 raised to the power 4 is 3 raised to the power 2 plus 4, which is 3 raised to the power 6. It means 3 is multiplied 6 number of times and the result is minus or positive 729. Third one, suppose the question is multiply minus 3 to the power 2 and minus 3 to the power 3. This will be minus 3 raised to the power 2 plus 3, which is minus 3 to the power 5. It means minus 3 is multiplied 5 number of times. It will be minus 243. Second law, if A is a non-zero integer, which is a base, if m and n are the powers, if m is greater than n, then a to the power of m divided by a to the power of n is a to the power of m minus n. If m value is less than n, then we get it as 1 upon a to the power of n minus m. These laws you must remember. Let's see example. Here there are 3 questions. We shall solve them. To begin with the first one, 3 raised to the power 5 divided by 3 raised to the power minus 6. Clearly m is greater than n. In such cases, a to the power of m divided by a to the power of n is a to the power of m minus n. Let's apply the formula. A to the power of 5 divided by it, here it is 3 to the power 5 divided by 3 to the power minus 6. So 3 to the power 5 divided by 3 to the power minus 6, this will be equal to 3 to the power 5 minus of minus 6. We get the result as 3 to the power of 11. Let's solve the second one. If 36 is divided by 32, this 36 is nothing but 6 square. 32 is nothing but 2 raised to the power 5. Their bases are different. In such cases, this can be written as 2 times of 3 to the power 2 divided by 2 to the power 5. This is 2 to the power of 2 into 3 square divided by 2 to the power 5. This will be 2 to the power of 2 minus 5. This will be 3 square. We get 2 to the power of minus 3 into 3 square. This will be 1 upon 2 cube. This is 3 square. So 9 by 8. To solve the third one, it is 1 upon 3 to the power of 6 minus 2. This will be 1 by 3 raised to the power 4. Let us see the third law. A and B are two non-zero integers. They are the bases. And m is a whole number, which is a power. Then a to the power of m into b to the power of m is equal to a into b raised to the power m. For example, I have got 3 questions here. Let us solve. Five square to the power 3, it is nothing but 5 to the power 2 into 3, which is 5 to the power 6. 33 square, actually there is a print mistake, it is 3 to the power of 3 whole square. This is 3 to the power of 6 because 3 times of 2 we get it as 6. Which one is greater? If you look at 5 square into 3, the meaning is this 25 is multiplied to 3, which is 75. 5 square whole to the power 3, the meaning is 25 is cubed. So 25 is multiplied 3 number of times, we get it as 125. Clearly, 125 is a larger number than 75. Therefore, 5 square whole to the power 3 is larger compared to 5 square multiplied with 3. Fourth law, if a and b are two positive integers, and m is the power, then ab to the power of m is same as a to the power of m into b to the power of m. When we have 3 into 5 to the power 4, it means that it is 3 to the power of 4 into 5 to the power of 4. If the question is multiply this, 3 to the power of 3 and 4 to the power of 3, we get it as 12 to the power of 3. This is same as 15 to the power 4. Fifth law, if a and b are two non-zero integers and m is the power, then a to the power of m by b to the power of m is a by b to the power m. For example, if you have 2 by 3 to the power 4, it means it is 2 raised to the power 4 divided by 3 raised to the power 4. 2 to the power 4 is 16. 3 to the power 4 is 84. Sorry, it is not 84, it is 81. The question is to divide 3 to the power of 3 by 4 to the power of 3. It is 3 by 4 to the power of 3. It can be written like this. Minus 7 by minus 4 to the power 4. Same as 7 by 4 to the power 4. Can be written like this. Now, sixth law, whenever we have any number to the power 0, it will be equal to 1. For example, if you have 3 to the power of 4 to be multiplied with 3 to the power of minus 4, this will be 3 to the power of 4 into 3 to the power of minus 4. The power should be added up. We get it as 3 to the power of 0, which is 1. So we can say that any number except 0 raised to the power will be always 1. Let us take this question, simplify and write the answer in exponential form. Let me take the first one. It is 3 to the power of 5 divided by 3 to the power of 8 whole to the power of 5. It is multiplied with 3 to the power of minus 5. Here the bases are same. If you look at the powers, 5 is a number smaller than 8. So the result has to be 1 upon 3 to the power of 8 minus 5. raised to the power 5 multiplied to 3 to the power of minus 5. This will be same as 3 to the power of 3. When 1 by it is there, it can be written as 3 to the power of minus 3 to the power of 5 multiplied to 3 to the power of minus 5. We get it as 3 to the power of minus 15 into 3 to the power of minus 5. So this is 3 to the power of minus 20. This should be added up. For the second one, it is minus 2 raised to the power minus 3 multiplied to 5 to the power minus 3 multiplied to minus 5 to the power minus 3. We all know that when 1 by a to the power of m is there, it is same as 1 by a to the power of m is there, it is same as a to the power of minus m. If this is the form, it can be written like this. So 1 upon minus 2 to the power 3 into 1 upon 5 cube into 1 by minus 5 cube. You must know that whenever odd is the power, the value will be negative. So we get it as 2 cube multiplied with minus 1 into 1 by 5 cube. This will be 1 by 5 cube multiplied with minus 1. If you observe, this minus 1 into minus 1 will be positive 1. So the result whatever we get is 1 upon 2 cube into 5 cube into 5 cube. Now the powers are same. So 1 upon 2 into 5 into 5 raised to the power 3. So 1 by 50 cube, or it can be written as 50 to the power minus 3. With this question, I'll end today's session. Thank you.